Ladies and gentlemen, this is a lightning talk 2 for the APAC DNS Forum session. I'd like to remind you that you can win prizes by attending the forum sessions. In order to win those prizes, we need you to attend all the forum sessions, engage with speakers through the Q&A, and visit all virtual booths to collect the points. 10 participants who manage to collect the most points will receive an Amazon gift card worth 50 USD. So don't miss out on this opportunity. Now, our moderator for this lightning talk session will be Sabrina Lim from ICANN. Let us welcome her. Over to you, Sabrina.
Thank you very much, Isa, and hello everyone, and welcome back from the break. I trust you all had a good one. So this is the second of 2 lightning talks here at the APAC DNS Forum. As Izan mentioned, I'm Sabrina from the ICANN APAC office and your moderator for the next hour. So our lovely speakers today all come from strong research backgrounds as part of their expertise with a very interesting mix of topics for this talk. We'll get to them one by one and pause for comments and questions after each speaker. So if you have any comments or questions at all at that time, please feel free to raise your hand or type in the Q&A pod that you see in your toolbar. So with that, we're set for our first speaker, and it will be Davey. Davey is the senior DNS architect at Alibaba Cloud. He also has more than 15 years of research experience in internet architecture, especially in IPv6, DNS, security, and privacy. So what is Alibaba's best practice in DNS infrastructure for tenants in a cloud environment? Over to Davey, please, to tell us more.
Thank you, Sabrina. And I need to share my screen, right? Okay. Is that okay? Can you hear?
Looking good. Maybe
my
just
voice?
if you could put it in presentation mode. Perfect. And you sound great. Please go ahead.
Okay. Good afternoon, everyone. I'm David Song from Alibaba Cloud DNS team, and it's my honor to be invited here to present slides to share. I would like to share some thoughts on the architecture design and some practice that my team are doing. So the majorly focus on the multi-tenant cloud environment. Okay, so firstly, I would like to introduce briefly what are we doing in Alibaba Cloud DNS. Just like many DNS providers, the public internet connectivities is handled and majorly by the DNS as a base. So we provide the manager DNS to help the customer to set up their own DNS settings without use the infrastructure of the cloud. And we also provide public DNS as the reserver, public reserver. And we also provide the cache public zone as a feature that can allow the enterprise to use our DNS infrastructure without changing their own the DNS system. That cache can pull the zone in our DNS infrastructure. Besides the public internet connectivity, we also provide the intranet DNS resolutions and DNS management. And we can see that the DNS for the VPC, we provide the private DNS zone that is hosted by the customer. They can define their own local names and zones so that they can do some testing and do some the local management of their resource, especially when the resource are put on the cloud. They have many services, the domains, localized domains that need to be reserved and managed. And we also provide the global traffic management that can direct the traffic to the exact and right place, so that people can enjoy the good experience, and also they provide failing over MAC reasons for our customer. And also we provide the anti-DOS protections and DNS firewalls for the some security attacks. So yeah, that's all for that's all for the picture. One picture for our provide services in one pictures. In the terms of design, there are three very key features of capabilities. It's very important in the design of DNS in the cloud. That's the first S is the stabilities that requires it requires the DNS services to be resilient and stable for the failures or some events, outages. So that's the first one, and the second one is the second S is the scalabilities. It's need our system, the DNS infrastructure should be easily and effectively to scale to large network, different scenarios to cover more millions of tenants in the cloud. And also we need to consider the security and also include the privacy in the design of the DNS in the cloud. So in this talk, I will focus on the scalabilities for the multi-tenancy environment. Okay, when we talk refers to the multi-tenant environment in clouds, there's a lot examples like similar like the cloud the hotel business or bank business that to provide there are many customers, right? They have their own customized requirements. For example, if I need to book a room, I need a queen size bed or French windows. So the hotel will provide the services for me. And it's similar business done in cloud that you utilize the infrastructure and provide services for many users, many tenants in the cloud. And especially in the DNS, different tenants may have different DNS configurations. One requirement is that they need to manage their local names, right? Just as I talked before, and they need to have their own local namespace that can handle easily. They don't need much change or cost to migrate their services from one place to another, from the local facility to the cloud. So the private hosted DOM is very important for them, and they also has different security policies. For example, they may deploy different RPZ policy, different feeds, and they also has different settings on the access control list. And they may also can have different requirements to purchase some services like the maximal the queries per second from each virtual machine or from each VPC. So in a nutshell, in the DNS, the multi-tenant DNS in the cloud should provide customized services according to their different configurations. So that's the major scenarios or the requirement we'll focus today. And it's also worthwhile to mention that in the cloud, just like enterprise network, they also has a split DNS requirement that they have local names to management, and they also would like need to visit the global internet to reserve the global the name space. So we also need to consider in the design. Okay, when we're talking about the requirement for the multi-tenant DNS design, I think at least two requirements are coming to my mind. The first one, and also the most important one, is to design a capability that can enable DNS server or DNS infrastructure to identify the tenant who sends the query. In other words, to identify the virtual network from which DNS query is generated. So that's the first and the most important things you need to think about. And the second one is that in the multi-tenant, the environment, the data isolation and privacy protection is very important. But it's glad that in the it's a nature advantages for tenants in different VPC, that the virtual network already isolates the traffic and the data, so it's we've been less considered in our design, and so we are focused on the first one, how to recognize, how to identify different variants. So when we're talking about the cloud that can serve multiple users, customers, there are one technologies that need to be reviewed as a short background. That's the network virtualization. Just like we virtualize our computing resource, we virtualize the network resource and the storage resource. Also, for each tenant, encapsulation and tunneling protocols are used to provide that to provide the customer, different customer by creating overlay networks that use the same physical network. And there are two notable virtual encapsulation protocol listed here that they are most commonly used to enable the use of more virtual network for different tenants. So there is a diagram here, and it's briefly describe how the different virtual machines are connected in a virtual network. That the original Ethernet frame will be encapsulated by the tunnel endpoint, one tunnel endpoint, and sent to another tunnel endpoint, server 2, and the packet will be encapsulated and sent to virtual 3. The virtual machines belong to the same virtual network because they share the same the VXLAN identifier. So there are two identifiers that can differentiate the different the virtual networks. That's the very brief how it works. But you may think about that when the different VM in different virtual network are talking to the their DNS server, it happens to be a tunnel endpoint. It's easy to think to design to have a design that the DNS tunnel endpoint server can recognize different queries from different virtual network by identify the VNI, right? The virtual network identifier. So, but it is not always the case that the DNS tunnel endpoint server provide all the capabilities or functions in the endpoint. So just like the different roles like local cache, reserver, firewall, assertive private zone, or some PCAP function entities may deploy in different servers in different networks. And they may as well, they may provide by different software provider as well. So if we put all the services or the software in the one box, that to understand the tunneling mechanism, that will require them to rely heavily on the network topology and the implementation of how virtualize the network. So I just list some solutions when we design the the multi-tenant DNS. So the one possible solution is to change the internal names with a suffix or prefix. For example, we put a suffix like the private TLD used in the local network with a tenant ID and as a suffix to the internal names, but it will require extra routines handling DNS message. You need to editing the names in the message, and also you need to consider the compression process. So it will require extra routines. So the second one possible solution to use the variant of bind multiple views. Yes, when we talking about different users, we may first the solution the first solution will come to our mind is the band provide multiple views, but it depends. It relies on the recognition of the source IP, and it in the band implementation it cannot provide cannot scale so much large group of tenants, millions of tenants in the cloud. So and as far as I know, there are some solutions to change the band multiple views as a variant, but it requires some source IP and port translation at the NAT function as in the DNS the tunnel endpoint, and it also adds complexities. And people
Hi, Davey, sorry.
Mm-hmm.
Davey, sorry. Would you be able to wrap up in the next few moments because we still have speakers to get to? Sorry about that.
Okay, I will quickly finish that. And I think many DNS guys may refer to the utilized proxy to the same result. So I just list some extra work and some cost it may happen. So in Alibaba, we would like to achieve more flexibilities in DNS deployment and development by decoupling DNS and network virtual technologies. So that's the last page that we introduce a new EDS options for the virtual network identifier, and I summarized the practice in the draft. I'm going to go to the ITF DNS op and ask for more feedback. I think it's very intuitive that to assign the value from the virtual identifier of the virtual network to the EDS virtual network identifier. That value are the same. So yeah, that's all for my slide and presentation.
Thank you so much, Davey. Thank you so much.
Sorry for.
I'm so sorry to have to rush you
time.
through that. No, thank you so much. This is really interesting work from Alibaba that really showcases how customization can be configured to a high degree for its customers. So are there any quick questions here for Davey? Please feel free to raise your hand or put them in the Q&A pod. There is a question here from Nura Muhammad. Can the Anycast feature be enabled to have better redundancy?
So I think for the redundancy for the DNS for the tenants in the cloud, I think is the first step is to recognize them and identify them. So all my presentation are focused on that part. If you identify which the virtual network the query is generated from, then you can customize their resource. I think you can generate the redundant instance for the DNS resolution, and you can provide more the maximal query per second capabilities for the tenant. So I think it's very flexible if we can firstly identify the different the tenants and provide the redundant services, DNS services based on their how to say the configuration. Yeah.
Thank you so much, Davey, and thank you so much, Nura, for the question. If anybody has any other questions, please feel free to pop them into the Q&A pod. But for now, let's move on to the next speaker. So If you joined our forum yesterday, you will remember Mayan from the very exciting Future of the DNS session. Yes, hello, Mayan. Mayan's the director of the Fair Tech Institute at the tech consultancy firm called Access Partnership. So today, Mayan will talk about something slightly different, which is focused on emergency communications in disaster management. So welcome back, Mayan, and please go ahead.
Thank you, Sabrina. All right, just double checking that all of you can hear us. Can you hear me? All good? All right.
Great. Yeah.
Great. I believe that I have already screen shared, so you should be able to see my screen. I will not be going into presentation mode because then everybody can look at how many slides does she have left. Why is she so long-winded? And you can tell that I've only got 9 slides. So I will be speaking pretty quickly. So Sabrina, if you're a bit, and if for you guys, if you've joined us and if you're looking like at your clock and like, oh, is this probably going to be running over time? I will try my very best to keep this pretty short and sweet because I do have some questions around the DNS and satellites. So if you're thinking, hey, Mayan is the Emeritus Director of the Asia Cloud Computing Association, is she going to be talking about clouds? Answer is yes, I'm actually going to be talking about clouds now. All right. So the topic that I'm going to be chatting about today is actually emergency comms and disasters and crises. Is there a safe space for DNS? So I'm gonna share a couple of statistics for you, but before I get to the statistics, I'm gonna give you the key takeaways. So this is the answer key already. I'm gonna give you the answers like what is the point of this session? I need to do my write-up. What I'm gonna tell my boss. This is the slide that you're gonna take a screenshot of, and then you write out and tell your boss, Mayan spoke about these things. All right. So the 4th key takeaways from my message is that number 1, I think that there is a global and universal need for a disaster and emergency communications. I think that over the number of years that we have existed in the last 10 years, we know that, oh my gosh, that there've just been so many disasters and crises across the world. And I mean, particularly in Asia, and that's really, really bad. My second point is that the economic scaling for satellite communications has not yet been realized. You've got people who have, put satellites up in space, but it's not been realized. Right now, we do have on terrestrial communications, we have tower sharing abilities, etc. We're only starting to do that with satellite sharing facilities. We've not quite gotten to the point where it's economically feasible for anybody and everybody to so I won't say anybody and everybody, but people who are in the telecommunications sector to actually branch out. Not quite. I'm saying we're sort of there, but not quite just yet. And this is unfortunately coming at the expense of human lives. And it's actually really disproportionately being carried by the less developed countries. A lot of the less developed countries are paying the price of this economic scaling not being quite there yet. Now, the third point is that there is a complement between multiple networks for disaster management and the need for disaster management. No single deployment model will actually be feasible. And I think for those of you in the internet space, I don't need to talk about this. Redundancy is all we're talking about. I think even the question that Davey had answered is also about redundancy. So no single model is sufficient. We need to have more models for satellite communications and disaster management. And number 4, which is where DNS plays a role, regulatory and policy flexibility is needed for effective and timely intervention. And this is vis-a-vis the licensing and authorization frameworks, standards, and interoperability. So that's a question of at the bottom, you can see in small letters, DNS what? DNS how? I mean, how are we going to fit all of that in? Very quickly, just running through some of the statistics. There are national emergency telecommunication plans, and they're all centered around 4 things: mitigation, preparedness, response, and recovery. Communications will underpin all of these things, and it's really, really important for us to make sure that response and recovery in particular are covered. How communications is compromised, and this is where we're going to be looking at where DNS and where we can play a role. Strong winds and flooding damaged cables between cellular towers, so there's terrestrial damage, seismic activity damages underground and fiber optic cables, heavy rain and snow, cuts off wavelength signals to important wireless links. Solar storms destroy cellular satellites. Networks often become congested and jammed, especially when you have almost all of the channels being closed and only one little channel is open or undamaged in a disaster, then you have a little bit of a problem. So what we're seeing in Southeast Asia, we're massively heavily impacted, and These are just statistics which I know all of you are more than well aware of. We're just seeing a lot more natural disasters. And here's the disaster toll on people's lives. We have a lot of people displaced due to natural disasters. So obviously this is a massive and important thing that we need to focus on, because if we are able to anticipate, if we are able to mitigate, again, coming back up to this one, if we are able to mitigate, if we are able to prepare better, if we are able to respond better, if we are able to recover better, we will be able to stop at least not so many millions of people being displaced, but at least we'll be able to mitigate some of that harm being done to people. And the thing is, it's really important. It's really important in particular for disaster management, because in disaster management, every minute matters. For those of you who have ever walked out of your house and you've forgotten to bring your mobile phone, you know what that minute means, right? That minute, just to double check and say, I want to take my phone. Every minute matters in a disaster. And so what are our methods for phoning home in a disaster? We've got terrestrial walkie-talkies, we've got satellite phones, we've got amateur and citizen band radio, and we've got cellular networks. Now, questions around modern emergencies and questions. Does the app generation know how to call emergency anymore? I'm not actually kidding about this, because some people actually don't know how to call, don't really know 999 or 911 or 119, whatever the emergency numbers are in your location. And here's another weird thing. Is there a psychological barrier to talking right now? Because everybody's sort of like texting now. The younger generation in a disaster, they might be like, oh, okay, who do I call? I don't know who to call. And who do I text? I can't text. What am I doing? I mean, is there a psychological barrier to this? So that's a really modern type of emergency and question. In an emergency, we need to make sure that we're aware that we need to do some awareness of the power rationing that happens with people. Maybe if they're buried under rubble, or if they're in trouble, you may want to have a way of a low bandwidth, low power solution to communicate, so that they can check in maybe every hour, so as to reduce power consumption. Remember, everything's broken. You're not going to be able to recharge your phone. You only have your battery, and whatever is left is basically your lifeline. And right now we're seeing in modern day satellite phones right now, they're mostly carried by rescuers. They're light in bandwidth demands. I think maybe one of these days is going to be coming to the consumer soon. If that's the case, then the proliferation of consumer grade satellite phones is something to be looking forward to. And I think that we need to increase the resiliency of the comms systems for the NGO, the government and private sector. We need to increase available channels to communicate when dealing with the characteristics of a disaster where you have no power, limited time to react. You need to take into consideration the digital literacy of the population. So what are the implications on the DNS community? And this is my last slide, because the actual last slide, number 9, is just a repeat of the first slide. Implications on the DNS community. As the satellite phone networks grow and various models come into the market, especially for the consumer market, there'll likely be a growing demand for sat phones with smartphone capability. So maybe limited, we're not pretty sure. This may have better use in allocation of data transfer rates. So for example, sending messages versus having a voice call, especially important during disaster. And I mentioned already why you may want to actually get people to text rather than to talk, especially if it has to do with battery consumption. So questions around the APAC DNS community. Do we have a platform for such emergency comms? Do we have special reservations for satellite IPs? Is it a time for us to talk about sort of emergency type DNS, which can be accessed by any kind of phone? I'm not quite sure whether these questions have already been answered, but I want to just pose it up. And if you have the answer, please just tell me in the Q&A. But if you think that this is interesting, also just let me know in the Q&A, because I think that this is quite interesting sort of approach that we may want to think about. Are there any existing discussions with companies and firms now regarding anticipated or expected data transfer issues, especially if it regards to consumer-facing satellite phone development? Because I think we need to start thinking about future-proofing the DNS, the APAC DNS in particular, against any sort of market shift. So having that sort of early chats with the market may be actually pretty useful. So that is the end of my presentation. We do have a report that's coming out, the Fairtech Institute. We do have a report coming out. It's the role of satellite communications in disaster management. So if you would like me to send you a copy when it's ready, please let me know. Just ping me and drop a note in the Q&A section with your email. I'll keep you in loop. I promise I will not be putting you on any mailing list. I'll just send you the document. All right, that's it for me. Thank you very much for listening. And Sabrina, back to you.
Thank you so much, Mayan. Really, really wonderful points there. And I think a lot of food for thought in terms of the kind of, how critical all these kinds of issues are and what are people thinking about them. Is there a lot being done? Is there enough being done, and where and how? A lot. Are there any questions, quick questions, comments? Anybody with burning things they might want to know from An? Okay, man, I already have requests to get your report in the mail to some people on this call. That's wonderful. Thank you so much, Cheryl. Anybody else with any other quick comments or questions? Or while you're thinking and trying to digest all of that, perhaps we can move to the next speaker, and then we'll try and come back to you all again a little later. So thank you so much first, Mian. Wonderful presentation. Okay. So next up, we have Feng Lu, who is a PhD student from Tsinghua University, also a member of the Network and Information Security Lab. He has been focusing lately on the efficiency and security of DNS servers, and his topic for us today is on the effects of deploying root server instances in China. So welcome, Feng Lu. Over to you, please.
Okay, thank you for your introduction. Let me share my screen. Can you see my screen?
Yes.
Oh, okay, let's start. Hello, welcome to Measuring the Practical Effect of DNS Root Server Instances, a China-wide case study. I'm Feng Lu Zhang from Tsinghua University. Root servers are essential for the DNS resolution process. They are the starting points of domain name space and bootstrap all DNS queries. To resist denied of service attacks and improve stability, all 13 root servers are deployed anycast. Multiple root instances add collectively behind. In recent years, root instances are deployed rapidly. From 2019 to 2021, the number of root instances increased by 43%. However, the practical effect of these instances remain unknown. Specifically, which networks are within their catchment area, which networks are still not served by closed instances, and how are they absorbing DNS root queries from nearby recursive resolver? We tried to answer this question in a China-wide case study. Let's move to our methodology. A challenge is we need to identify the exact instance that responds our queries. We turn to answer another question. Are queries resolved domestically or overseas? We present a method to determine it by using DNS censorship. Consider our vantage point send a query with a censored domain to a root server. If the query is answered overseas, the censorship system will detect it and inject a fraud response. If the query is answered by a domestic instances, our vantage point will receive a normal response, since it doesn't pass the censorship system deployed at the international gateway. Now, we can determine if domestic instances serves queries from our vantage point. If the query is answered by an instance deployed in overseas, a fraud response with a censored IP address will arrive. If the query is answered by a domestic instance, a normal response will, with delegation data of top-level domain will arrive. Let's move to our measurement and the result. We select 182 vantage points. They covered 4 major networks in Chinese mainnet, including China Telecom, China Unicom, China Mobile, and Cernet. Considering network policy may differ in different Chinese provinces, our vantage point had great Poran's coverage. We also filter the vantage point affected by DNS hijacking. Our measurement is designed to answer 3 questions. The first question is, which networks are served by domestic root instances? Let's focus on the result of China Telecom. Here is a heat map. X-axis represents each vantage point we had, and the Y-axis represents querying to each root server. The darker cells indicate that more DNS queries from the corresponding vantage point are resolved by domestic instances. We find that except for F, K, and L, almost all queries to other routes are responded by overseas instances. However, in Chinese mainland, root instances for F, I, J, K, and L are deployed. We also had similar findings in other networks. In summary, domestic instances help queries in domestic. However, we also find that some networks are not served by domestic instances. Now, we try to answer, why are some networks are not served by domestic instances? Through measurement and discussion, we review the reason behind. The first reason is the location of root instances. Root instances in Chinese mainland are hosted in one ISP network. The second reason is that major ISP networks did not directly pair with each other. Besides, limits of BGP routing policies also prevent root instances sharing. Now, let's move to the last question. How do domestic instances affect root server selection? The first finding is that domestic instances contribute lower delay. Domestic K-root instances can be accessed by telecom and Unicom network instead of mobile network. And we find that the delay to K-root in telecom and Unicom is far lower than that in mobile. The second finding is that DNS recursive software prefer DNS route with lower delay. We analyze 4 popular open source recursive DNS implementation. And we provide the first analysis of DNS route server selection through source code reviewing and dynamic debugging. We find that all of the 4 DNS implementation we use authoritative server selection algorithms. And the band, night, and NOT resolvers preferred root servers with the smallest RTT, while unbound and power DNS tend to select root servers randomly, despite that they are designed to consider RTT. Consider market share. Domestic instances effectively absorb queries within their catchment. Finally, we provide a recommendation for issues we found. The first recommendation is that BGP pairing with the root server network. However, political and commercial interests should be followed first. And then, making BGP pairing information between ISP and the root servers more transparent is necessary. It's helpful for informing operator about whether their network can be served by root instances. Besides, for the developer of DNS software, we recommend to review whether DNS implementation is consistent with their original design goals. For DNS community, the status of root servers has been heavily monitored. Sister measuring root servers from resolvers' perspective still need to be developed. In this world, we provide a study for the practical effect of root instances in the Chinese mainland. We present a new way to measure the catchment area of domestic instances. And we have two main findings. First, some of domestic instances are not accessible from major ISP network. Second, the impact of deploying new instances on root server selection in recursive resolvers. We finally provide recommendation for improving the practical effect of domestic root instances. Thank you for your interest in my presentation. Wish you have a nice day.
Thank you so much, Feng Lu. That was really very interesting findings. We got a comment asking if you could show slide number 14 again. I think that's the China Telecom slide. Could this person who asked for slide 14, do you have a question that you might like to ask? Please feel free to raise your hand or type it into the Q&A pod so we can help you. In the meantime, if anyone has any other questions or comments for Feng Lu, please feel free to also raise your hand or type in the Q&A pod. For people who are curious about the presentation slides, not to worry. We'll be uploading all of today's session slides into the virtual platform after the session, so you'll be able to find a copy of everybody's slides there, including the email contacts of all our speakers, so you can always reach out to them as well. Okay, I don't see any hands up or any further questions at this point. In that case, then, thank you so much, Feng Lu.
Thank you, thank you.
Thank you very much. Okay, so moving to one more speaker that we have, and this is Tom. So he's a researcher with NetTalent and the registrar Net Chinese. He comes with practical experience related to internet policy and DNS abuse. If you've seen our pre-forum webinars before, you might remember him as a speaker from there. Now, we've been hearing a lot about DNS abuse these 2 days at the forum, and Tom is going to give us a slightly different part of the abuse picture. This one is going to have to do with processing of child abuse related content. So to tell us more, Tom, please go ahead.
Thank you, Sabrina. And I'll be sharing my slides first. Can everybody see my slides?
Yep, looking good.
Okay. Okay. Good day, ladies and gentlemen. I'm Tom from Net Chinese and NetTalent. And Net Chinese is an ICANN accredited registrar, registry, and registry operator. And NetTalent is a research entity established by Net Chinese. NetTalent employs a team of legal, technical, and language specialists to take on the role of a frontline observer of internet governance, diving deep down into the various topics of internet governance research, achieving global participation and market capabilities. And today I'll be speaking on DNS abuse handling in the new era from a child abuse content perspective. And the issue of DNS abuse sparks global focus in recent years and has been one of the most important problems and most widely addressed issues since the invention of the internet. This is a matter that spreads beyond ICANN into the hearts and minds of governments, communities, IGOs, and NGOs. There have been many research by many entities and organizations on abuse. For example, the research by Internet and Jurisdiction Policy Network in recent years, and also the report Study on Domain and System Abuse by the European Commission, published this year. These reports all aim to try and find a solution to mitigate abuse. We at Net Chinese and NetTalent try to provide a hands-on perspective on this matter. Now, before I go into the slides, I'd like to briefly explain the terms CSAM and CSEM. CSAM stands for Child Sexual Abuse Material, and the term can be used as an alternative to child pornography for material depicting acts of sexual abuse and or focusing on the genitalia of children. Now, CSEM stands for Child Sexual Exploitative Material, which is a broader sense to include all sexualized material depicting children and includes CSAM. And for the outline of my presentation, first I'll be speaking on CSEM status, and then I'll be speaking on the NetTalent CSEM takedown program, and thirdly, the DNS abuse challenges and requirements, and moving on. And first, NCMEC stands for the National Center for Missing and Exploited Children. And from their information, or from these statistics, you can see that 99% of the abuse cases are CSAM abuses. And since the pandemic, there's a clear increase in the number of CSAM reports, 28% from 2019 to 2020, then 35% from 2020 to 2021. And these year-on-year increments clearly indicate the seriousness and severity of CSAM and the urgency that government, society, and industry needs to act upon. The other important issue is the speed and rate that these abuse contents are re-uploaded and given a new title. And these abuse content may not be fully reflected on these numbers and charts. And next, moving on. Now we see, now look at the type of sites that these abuse contents are found. And this section of information is sourced from InHope. And we can see that websites, image hosting, file hosting, and internet forums constitute majority of the sites that are reported. And we can also logically assume that these sites also provide online storage to their users. However, these are now being misused by people. And moving on. And now to the fourth slide, we're now looking at the report cases in Taiwan. And these stats are taken from the Ministry of Health and Welfare. The stats show that there's a general increase to the total number of cases reported, and also with cybercrime cases. We can see that the cybercrime cases are increasing at a rate of around 300 cases per year, which equates to around 30% year-on-year increments. And with the distribution tools being websites and communication apps primarily, with 46 and 42% respectively, totaling nearly 90% of the cases reported. And the statistics from these three slides indicate that there's a steady increase in both the reported cases and also cybercrime cases, and that these CSEMs needs to be dealt with swift action, as these actions are against the original intent of the creation of the internet. The creation of the internet fosters rapid exchange of information and increases the speed at which research and experiment results are achieved. And this is the original intent of the internet, to my understanding, and not to be misused and put children and future generations in harm's way. And this is where NetChinese and NetTalent invest the time and effort doing our part of corporate social responsibility to make this world a better place for everyone. Now, this slide I'll be speaking on the CSEM removal program. NetTalent is currently experimenting with a global child sexual exploitation material removal pilot program. We aim to help remove CSEM and exchange experience with other content removers as well. We are an experienced team with years of internet industry and research experience, and we have a passion to make the internet safer for everyone. Our methods are simple: to seek and remove the reported content. And we will go through the web with our program to find the related content and analyze possible actions, then report them to the relevant parties to remove those content. Our guidelines are aligned with freedom of speech, procedural justice, and principle of proportionality. And through the program, we plan to analyze and integrate a possible method or solution, a possible course of action to bring the players of internet services together to act on these CSEMs, and encourage all players and stakeholders to work together to protect our youth and future generations. And this is a major task and project. And our belief is that not all abuse needs to be handled at the DNS level. And we welcome all interested volunteers. And we also would like to explore and find the conditions that will attract players to volunteer and join our cause and address this issue. And now, lastly, move on to the DNS abuse challenges and requirements. And this is not just a challenge or requirement for us, but also a challenge for all content processes. Firstly, we still lack a definition of DNS abuse that will enable a swift and immediate action on CSEMs, because current definitions of DNS abuse are primarily targeted at technical abuse. And secondly, because the internet is borderless, and this becomes a challenge because the actors now crosses border freely when spreading these contents. However, we as abuse content removers still need to face the issue of jurisdiction when we are processing any cross-country abuses. And thirdly, the lack of internationally standardized policies and practices, and this makes combating cross-border abuse a challenge. And with regards to tools and skills, to search to find the correct content and to find the correct sites that they are hosted on or that they're posted on is very crucial, so that we can correctly and efficiently remove these contents and also to analyze the best methods to remove them. With regards to process and communication, with regard to any abuses, there are time zones to be considered, national circumstances to be considered, and even when speaking or writing, the tone and language is also criteria that needs to be carefully considered. And abuse mitigation is one of the major challenges that we are facing since the invention of the internet. And we hope to build a safe and harmonious internet for everyone. And that's all I have for you today. Thank you.
Thank you so much, Tom. Thank you so much for sharing this very, very important area of work. So might anyone have any questions? Okay, I see one question from Ai-Chin, which is, when you remove and take down the content, do you need some legal enforcement to assist you?
It is obviously best to have court orders, obviously, or basically a ruling of a court that will make processing a lot easier. I guess that would be very similar cases around the world. Thank you.
Thank you, Tom, and thank you, Ai-Chin, for the question. Are there any other comments or questions, or anyone would like more details and clarifications for Tom? Okay, if there are none for now, we still have a couple of minutes left. So might anybody have any questions or comments for any of our speakers today? Please feel free. I think they've given us a lot of really, really good food for thought in so many different areas to take home. In the meantime, maybe while everybody's having a think about that, perhaps if I may try a question for Fenglu.
Yes.
So Fenglu, could I ask, is there a reason or a purpose as to why it seems like network operators don't share root instances?
Yes, that's a good question. In our work, we find 3 technological reasons preventing root instance sharing. In China, root instances are located inside ISP networks instead of IX nodes. And furthermore, the pairing between ISP network is leaking, and the BGP routing policies of networks are limited. I guess the original purpose of not sharing root instances is caused by commercial consideration. Because root instances are located inside ISP network, the ISP may be not willing to share with other networks due to commercial consideration. That's my opinion.
Thank you very much for that. I think that also really helps to clarify and give a bit more detail to the picture of how all these things sort of work behind the scenes, because I'm sure also we have a number of folks in the audience who may not come from technical backgrounds. So hopefully these little nuggets of info may help. Are there any other questions or comments for our lovely speakers today? In any case, not to worry, you'll be able to get their contacts from their slides, which we will be uploading into the virtual platform. So with that, that's about it for today. And I'd like to give a huge thank you to our wonderful speakers for all their various insights and the very much wonderful food for thought. On behalf of ICANN and MyNIC, I thank you all as well for being here with us. Thank you, everybody. So now I'd like to hand the time back to our MC, Izan.
Okay, thank you very much to our respective speakers for all of those very interesting topics. They have provided plenty of food for thought for us. And also I would like to thank Sabrina for being the moderator for the lightning talk. Now, before we go, I would appreciate if you could kindly answer the survey that will pop up in front of your screen right now. Okay, now if you have more thoughts to share with us, you could convey it to us through the form that has been provided in the chat box. On top of that, I really hope that you don't forget about the Amazon gift card that you could win by collecting the most points. Now, for more details, you may visit apacdnsforum.my. The next session is going to be on thick or thin registry and data escrow for CCTLD and GTLD. It will start at 3:15 p.m. in UTC+8 and UTC. Take care and we will see you there.